Hey all, this is Shiva Prasad. Welcome back to my channel. Today we are going to solve one more problem from our Leetcode 75 questions list. This problem is all about finding a majority element. So when we say majority element is when an element appears more than n by 2 times. Okay, so you will be given one input. Maybe you can think like 3 comma 2 comma 3, where size of this is n. I mean to say 3. Right. So the majority element is the element which occurs more than n by 2 times. So here 3 occurred 2 times, 2 occurred 1 time. So n by 3, sorry, n by 2. So what it returns you 1. So here 3 occurred, that is 2 times it occurred, which is greater than n by 2. So you need to return answer as 3. That's it. If you have another input something like 2 and then 1 1, so here n value is 5 and 2 occurred 3 times, 1 occurred 2 times, n by 2, that is nothing but 5 by 2, that is nothing but 2. So here 2 occurred 3 times, which is greater than n by 2, that is nothing but 2. So you need to return output as 2. I hope you understood the problem statement. Let's try to see how we can solve. I'm going to take a good example, maybe this one, 2, 2, 2, 3, 4. Okay, so we know like here 2 is the answer. By the way, it doesn't mean your input is sorted all the times. You can see here it's unsorted, here it's unsorted. So just my example showing you as a sorting. That's it. So different ways through which we can solve this problem. The very first way is sorting. Okay, why I'm saying sorting? So let's assume if this is sorted, so it remains the same, right? 2, 2, 2, 3, 4. So once we sorted, if there is an element which is major, that means the middle element is going to be the answer, right? Because we are saying it occurs more than n by 2 times. So that means your middle element is the perfect answer. You just return if length is n, so nums of n by 2, that's it. The second index is your answer. This is the first approach. But time and space complexities, time is big of n log n, right, to perform the sorting on this one. And space is big of 1 because we are not taking any additional space. We just return out of it. This is very first approach, sorting. Okay, maybe I can quickly write for you and then we'll go on the next step. So arrays dot sort of nums. I'm just sorting it and then I'm return nums of nums dot length divided by 2. Alright, so let me run it. Yeah, let me submit. Yes, it got submitted successfully, right? But I personally not feel happy with this approach. Is there any approach through which we can reduce this time complexity? Yes, using the hash map. Hash map. So what we are going to do here is, if our input is of something like this, we first count the occurrences of each element. You know, in hash map, key is always unique, right? Hash map stores data in the form of key value pair where key is always unique. So how we are going to do is, we going to keep key as 2 and its value is number of times it occurred. That is nothing but 2. Then we have key as 3, number of times it occurred 1. Then 4, it occurs 1. Once we iterate through this, we are going to have what I can say, our HashMap data in such a way that it stores key and value like this, number of times it occurred. So then second time we go through this one and we check if this number, let's assume second time I'm iterating. So actually this is a two pass solution. So basically second time what I do is, whenever I come to this, right, I start with for this, then I check if the value of this, that is the occurrence of this, is greater than length divided by 2, where n is the length of array. If that is the case, then I don't need to look about anything because answer is this only, right? Then I can return this immediately, right? So this is the second approach. So what is the time and space complexity? So time complexity, first it's big of n for iterating through this and to fill the map, and second time it's big of n again to iterate, assuming there is no major element, then you need to iterate through complete array to check how. So basically it's big of n only. It's to n, actually we ignore constant, as you know. The in space complexity is also going to be big of n because we are going to insert the complete input data into this hash map, right? So compared to previous approach, the time complexity is bit better, right? So let me quickly submit this solution also. Actually, I submitted already to save some time. So here is this one. So I am taking this into the consideration. So map hash map, and I'm iterating through the nums. I mean to say, then map dot put get our default basically returns you the value if it is already exist. Otherwise, it returns you the second parameter, that is nothing but zero. So whatever it is, so we are just appending one to it. If given number is not occurred, it returns zero. Zero plus one, that is nothing but one. That means the number is now going to have only one as a value since we are already visiting it. Then what I'm doing is in second pass, so I'm iterating through the key set. I'm checking if the value of given key, okay, is greater than n by 2, then I found my answer. That is my answer, right? Then I'm returning here, and otherwise I'm returning 0 at the end. Okay, so let me submit this one quickly. So yeah, it got submitted successfully. It took 14 milliseconds. That's great, right? So here still I'm not satisfied because there is one more approach through which we can make it more beautiful and more optimized. So the third approach is called Moore's voting algorithm. Voting algorithm. So, what does it mean by Morris voting algorithm? So, for that, I request you to spend some time on going through some YouTube videos or else the articles written by them so that you can understand. But on a high level, I can give you a quick overview. So, if my input is something, okay, 3, 4. And you have to remember Morris sorting algorithm works only if it assumes actually there is a major element which occur more than n by 2 times. Okay, if your input is not having such element where it occurs more than n by 2 times, then you feel this algorithm is not going to work. Okay, in order to understand, in order to agree with this algorithm, you have to take an input such that there is at least one element which occurs more than n by 2 times. Okay, so let me quickly explain you. So there are two types, there are two steps in order to solve this particular problem using Morris voting algorithm. The first one is we try to find a candidate which we assume as a which we assume as a major element, The second one is we verify it whether the assumed candidate is actually a major element or not. Okay, so how does it goes is, so we are going to have two variables, say count and then candidate. So the candidate is potentially a major element if the number is occurred more than n by 2 times. So initially counts start with 0 and I'm starting with the candidate with the 2. That is nothing but my very first element. So I am assuming it as a major element. So how does it go is, so basically, when this when the current element is equal to the candidate, then I am going to increment count. If it is not equal, I am going to decrement count -1 here +1. If count is 0, then I change my candidate to whatever the current value, current num. Okay. So, okay, let me explain you quickly by walking you through this input. So basically, as I said, I am going to have a count and then candidate, right? Candidate. So initially count is 0, candidate is 2 because this one. Okay. So what I'm going to do here is I check whether the 2 is equal to candidate. Yes, then count is going to be incremented. Then I come here. Is 2 equal to this? Yes, count is incremented by 1. Then I come here. Is 2 equal to this? Yes, count is incremented by 3. Then I come here. Is 3 equal to 2? No. Then count value is greater than 0, right? That means I decrement count by 1. That means the count value now going to be the 2. But candidate still remains 2. Candidate changes only when count is equal to 0. Okay, otherwise candidate remains the same. Then I come to here 4. Is 4 equal to 2? No. Then what I need to do? I need to decrement the count. Then count equal to 1. And we're done with iterating through the complete array. And what is the candidate now? 2. Right? So then what we are going to do? Then we are going to check if the what I can say to the candidate which we found is a major element or not. Right? So in this input, yes, it's major element, then you can return candidate here only, but you need to still perform a verify operation that I feel. So basically you iterate through this one, and whenever you check this number, then you can reset count to 0. So basically this count we are taking just for sake of finding a candidate. That's it. It doesn't have to do with your result. Okay. Then I'm resetting count equal to 0. Then I'm going through this array one more time. Okay, the second pass you can think of. So if 2 equal to count, yes, then increment, sorry, candidate, increment the count. If 2 equal to this, yes, increment the 1. If 2 equal to this, yes, increment the 1. Then 3 equal to this, no. 4 equal to this, no. So basically in second pass, we just find the occurrence of the candidate. If this count is, whatever you got count is greater than n by 2, then you found candidate is your answer. Candidate is your answer, right? Else it's not your answer. So the time complexity is big of n plus big of n, and which is equal to big of n. The space complexity is big of 1. So which is good, right? Compared to previous two, what I can say, approaches, because here we are sacrificing time complexity and here space complexity. But in this approach, you can see space and time complexities are bit optimized, right? So that's all the Morris voting algorithm. Okay, let's go and quickly write our code from scratch here. So as I said, I'm going to take int count, which is equal to 0, then int candidate. So I'm pointing this to nums of 0. Okay, the first one I'm thinking as a major. So what I'm going to do for nums, iterate I'm going to iterate through all the numbers in the element. So if my count equal to 0, then what I said, if that is the case, your candidate is going to be the your current number, right? Candidate is going to be the current number. So if this is not the case, okay, if this is not the case, then what you need to check, if is your number equal to candidate, that means candidate is 2 and second visit also it gives you 2. Then what you need to do? You need to increment count plus plus. You need to increment count. Else you need to decrement count, right? So actually here also you can return candidate. Okay, because as I said, in this like as I said, Morris voting algorithm always assumes the number is always major. There is a major element which occurs more than n by 2 times. So I can return here candidate, but let's see by running this whether it works or not. And I write one more step maybe. Submit. See, it got submitted successfully, right? So now here is the homework for you. Why I am writing this second for loop. Okay, so what I'm doing is for int, I am setting count equal to 0 here. Count resetting count to 0. For int I equal to 0, I less than nums dot length I plus plus. Okay, if if nums of I equal to candidate, okay, then count plus plus. Okay, then you can return if whatever the count you got which is greater than nums dot length divided by 2. If it is greater than this, then you can return your candidate. Else you can return 0. Let's see this one. Okay, candidate 0, return not a statement, it's saying candidate. If count greater than nums dot length divided by 2, in that case return the candidate whoever we found it, else return 0. Okay, here it is the question mark, here it is the colon, because this is the condition. which returns you either true or false. Okay, it's done, and then let's submit it. Yeah, it got submitted successfully, right? So now you can observe one thing. So even writing without this for loop, in the first submission, I written candidate, still it worked, but I wrote this one. So now here is the homework, and you need to comment on my video why this is needed. Okay, I request you to go through multiple input sets where there is no majority element and how this particular algorithm works. Okay, if you still don't find a proper explanation, you just comment on this video. I will create one more video where I solely focus on what does it mean by Morris voting algorithm and what are the problems we can solve through this algorithm. I hope you learned something new today. I will meet you in the next video, and don't forget to mark our tracker. So here it is major element we solve now. So I'm marking it as a done. So we are done 2 out of 11. So still 73 problems we need to do. Okay, that's very start of our journey. Okay, bye bye. Take care.